volume to max and to say EA Sports. It's in the game. If it actually works, it's like EA Sports. It's in the game.
Well, good afternoon, everyone. Hello there. Welcome to the Academy's Morrison Planetarium, which, along with the Academy and Golden Gate Park and the rest of San Francisco, is located on the traditional unceded homeland of the Ramaytush Ohlone people, who are the original inhabitants of the San Francisco Peninsula. Now, you're about to see a fairly new show for us. Began just a couple of weeks ago. Spark, the universe in us, talks about where the elements come from, the elements that make up everything, you and me and this theater and the museum and our entire planet. You think this stuff was just dug up out of the ground? You might be surprised to find out where it actually comes from. The show is about a half an hour long. It's narrated by Diego Luna. Partway through, I'll have a little bit to add, so you'll hear my voice again later on. But before we begin, we would like to remind you that, as with all of our presentations, we'd appreciate it if during this next half hour, if you please refrain from eating, drinking, snacking, or any kind of photography or recording. This would also be a great time to silence your personal electronics and to tuck away any light-emitting devices like cell phones, flashlights, tablets, etc. That light can be very distracting for the people sitting around you in the dark and can also interfere with the images that we project onto the dome overhead and can prevent you from seeing those images properly. So if you tuck those items away or turn them off, that would be great. Now, as with all of our shows, at the end, we ask everyone to please exit out through the doors at the top of either stairway, although if getting all the way up the stairs might be a problem for any of you, especially from the lower rows, just stay in your seat at the end, and our staff will assist you up the lower exits if that's more convenient. But everyone else, please use those doors up at the top. And because we've got a couple of school groups, it'd be really helpful if the school groups can stay seated at the end, let everyone else out first. That way you can all stay together and stay organized and no one gets left behind and mixed up with other groups. Okay, during this next half hour, during this presentation, we're going to be talking about things on a wide range of scales, things from as small as atoms to things that are just too big to imagine. We'll start with some objects, like stars, that are very small for stars. These are objects that are about the size of a city like San Francisco. Now, some of you know San Francisco is a medium-sized city. It's about 7 miles across, or 10 kilometers across, if you like to use that scale. And there are some stars that are as small as San Francisco. And then next up on our scale, a little bit larger than that, are things that are about the size of our planet, the size of the entire Earth, which is about 8,000 miles across, so about 1,000 times wider than San Francisco. And then up from that are things like the sun. Now we're going to talk about stars, and a good example of a star is our own sun, which is about 100 times wider than Earth, 1.5 million kilometers wide. And then next up from that, the next large step in scale is something about the size of our solar system. Now we'll use the orbit of Neptune as the limit. That's about 10 billion kilometers wide. And then up from that is what we call the interstellar scale. The interstellar scale, well, there's no one object that represents that size, but we'll pick an area that's about 20 trillion kilometers across. That's big. How big is that? It's big enough to encompass the 15 nearest stars to us. And it's a distance so great that it takes light 10 years to cross that distance. So astronomers say that this distance is about 10 light years across. We'll see some objects that are this big. And we'll show you those little icons, those graphics, to remind you of the size comparisons. We're talking about city scale, then planet scale, star scale, solar system scale, and then interstellar scale. So from time to time, we'll remind you of the size comparisons we're talking about by showing you these images compared to the other objects that we're looking at. So with that in mind, let's now have a look at where the elements that make up everything, you and me and this planet, and everything we see, where those things came from.
Everything you see, everything you touch, taste, and smell is made of tiny particles beyond the reach of our senses, called atoms. The iron and silicon in these rocks, the oxygen in the water we drink, in the air we breathe, the carbon and nitrogen in plants, even the gold in the mountains. These elements are the simplest forms of ordinary matter, each with a distinct type of atom. Some atoms have existed since the beginning of the universe, but most of the atoms around us formed more recently, inside distant stars. Virtually every point of light you see in the night sky is a thermonuclear furnace that turns lightweight atoms into heavier ones. Stars appear unchanging in our sky, but they power an elemental transformation that occurs gradually over millions or billions of